watch that video wherein I discussed on how to do the outlining of PMI, you would know that the first part of the proof would always be showing that this would work for the first element of the series, or the first element of the natural numbers, or the set of positive integers here, which is n equals 1. It was also noted in that video that you just have to denote the set S that would contain all the elements that would satisfy the equation right here. So we have now set S to be there. That's the reason why we have the statement right here as well in the proof. So considering that n is equal to 1, or showing that n equals 1 works, and that would be true for the first element right here, we have here k equals 1. And indeed, 1 works because we have 1 equals 1 times 1 plus 1 all over 2. Or, for the benefit of others, that's 1 equals 1 times 1 plus 1 all over 2. There. So in that case, the first part right here is already proven. Or considering that the fixed integer here is 1, so d is in S, or 1 is in S as well. Next, we assume that for this presentation here, it would be considering that k of them works, or that k would be element of S. So again, if you are having a hard time right now grabbing the idea, grasping the gist, it's preferable that you watch that video first, alright? The one that was suggested there at the top, at the upper right corner of the screen. Right, so in that case, since x is in S, that's part of our assumption right here. X is in S, that would be here. It would mean that x would satisfy the equation right here, right? Since part of the assumption would be x is in S or k is in S, it would mean that k or x would also satisfy this expression right here. So we can write 1, this predicate here, 1 plus 2 plus 3 plus until n, x or k that we're trying to consider here, would be equal to x times x plus 1 all over 2. That's this statement right here. Now if we are to add x plus 1 both sides, it would look like this. So you see, if you were able to watch WOP, or proving with the use of principle of mathematical induction, more or less we are having the same outline of the proof, alright? That's the reason why we discussed beforehand that in proving with respect to a set of integers, we can have either PMI or WOP. It just depends on your preference, and of course with the sensitivity of the problem that we got. So here, adding x plus 1 both sides, we'll have this statement here. And note that this left side of the equation will just be the same thing as this. And if we add x plus 1 to both sides of the equation, considering the right side this time, knowing that the right side has that's x times x plus 1 all over 2, so that we are to add x plus 1. So it would look like this now. For the benefit of others, that would be x times x plus 1 plus 2 times x plus 1, or that would be this part right here. Factoring out x plus 1 here, we'll have x plus 1 times x plus 2, and still all over 2. Notice that this would just be equal to this. Let's look. X plus 2 is the same thing as x plus 1 plus 1, right? And this one right here would still be just the same. Now what's with that expression? Knowing that the left side of the equation is 1 plus 2 plus until x plus 1, and the right side of the equation would look like x plus 1 times x plus 1 plus 1 all over 2. It means that x plus 1 satisfies the expression right here. Look, if we change this to x plus 1, this would also be x plus 1 times, this would still be x plus 1, then we still have plus 1 all over 2, and this would just be this, which is in line to these presentations of PMI, either of them, that if we assume that it works for x, or if it works for k, it would also work for k plus 1 or x plus 1. There. Alright, so consequently or accordingly, by PMI, this series right here is true. Just in case you want to dig deeper, and how come PMY really works in proving set of integers or set of natural numbers, click this video right here and you will be redirected to that detailed presentation, and you may also check some of the videos from this playlist as well. Alright, so thank you, and I hope you had subscribed already to this channel.